in this part of chemistry that is related to calculations in chemistry, we're going to talk about gases. And in gases, we're going to talk about the laws that are related to gases, like Boyle's law and Charles' law, Gay-Lussac law, and gas combined law, and also the ideal gas law, and what is the standard temperature and pressure, and also what is Avogadro's law. So these ones now, that's what we are going to discuss now. But first, as introduction, we all know what are gases. Gases, they are very small particles that they have no attraction or almost no attraction between each other. That means that attraction is very weak between their molecules, and they have no specific volume, but they take the volume of their containers. So we have a container here, and inside it is a group of particles of gases. They take the shape of the container itself. If it is circular, they take the circle shape. So that means they don't have a specific shape or a specific volume, but they take the volume of the container that they are in. Okay, when we study gases now and the laws that are related to gases, what do we study? Do we study them when they are on the air in the universe? No, that means what we study them when we study them here. We take a group of gases, number of moles of gases, we put them in a container, and then we study these gases. How we study them? We mainly study three properties or three quantities. We study what is the relationship between the temperature of the gases and the pressure of the gases, and also the volume of the gases, and how is that related to their movement. Okay, so these ones now mainly what we are studying. So that means it's related to the volume of the gases, how it increases and how it decreases, and to what degree we can increase and decrease these ones: volume, pressure, and temperature. If we see here now, and when we study, as we said, pressure and temperature and volume, so we are studying three quantities. When we study three quantities and the relationship between them, we usually make one of them constant, and we study the relationship between the other two. So here, if we make the volume constant, so that means we are studying now the pressure and what? And the temperature. Good. Then when we make the temperature constant, so that means we are studying the relationship between the pressure and what? And the volume. And when we make the pressure constant, so that means we are going to study the relationship between the temperature and what? And the volume. So that means we are going to study three things. So again, when we have three quantities and we want to study the relationship between them, we're going to make one of them constant. That means we didn't change its number, and we study the other two. How we study the other two? What does it mean we study the other two? How we study the relationship between the other two. That means we see if one of them increases, what will happen for the other one? Will it decrease or increase or not change? That what does it mean to study two quantities and the relationship between them. Okay, if we see just here for this picture, on this picture now, as you see, we have a container, and inside the container we have a number of gases. As you see, these ones are gases here inside this container now. And this container now has a specific volume. So the borders here, they represent what? The border here, they represent the volume of the container. And as a sequence, they represent the volume of these gases. Good. When we study now the relationship between temperature and pressure and volume, we're going to study, as you said, we're going to make one of them fixed and we study the other one. Okay, first, we're going to make the temperature constant. We're going to make the temperature what? Constant. Okay, the temperature now is constant. Good. That means now we're going to study the relationship between the pressure and what? And the volume. The pressure and the volume. Okay, and this problem here now, when the temperature is constant, that means here it is 150 Kelvin. Okay, what will happen now As you see, the pressure here is 11.3. The pressure here is 11.3 atmospheric pressure. Okay, what will happen? What will happen if we decrease the volume? If we decrease the volume, what will happen for the pressure? Okay, if we decrease the volume, by the way, this volume now, when it is decreased, as you see, what happens to the pressure? So when I decrease the volume here, as you see, what happens to the pressure here? As you see, it is increases. So that means the pressure here increases, the pressure increases when the volume what? When the volume decreases. Okay, what about if I increase the volume? If I increase the volume, what happens to the pressure? So as you see, when we increase the volume, the pressure will decrease. The pressure will what? Will decrease. Okay. Why does that happen? We're going to explain it when we study the temperature. So look here now, just what do you need to remember now on the first idea? And the first idea is that when the temperature is constant, the relationship between pressure and volume is inversely proportional. The relationship is what? Is inversely proportional. So that means if one increases, the other one decreases. And this one now is called Boyle's law. This one is called what? Boyle's law. Boyle's what? Law. So just to link them, remember that Boyle's is from the word boiling. That means related to temperature. So the temperature is constant. That means the temperature is not constant. That means the temperature is not changed in Boyle's law. So what Boyle's law states that at the constant temperature, the relationship between pressure and volume is inversely proportional. So that means when one increases, the other one decreases. Also, you can remember this point like if you are traveling and you have a bag and you put your clothes inside this bag. In order to add more clothes to your bag, as you know, then what you do, you usually decrease the volume of the clothes, right? So that you go to press these clothes down in order to what? To decrease their volume. So what do? You increase the pressure on them in order to decrease their volume. That's why you can add more clothes to your bag. So that means remember now, your bag or your traveling bag, remember this is Boyle's law. And you do that in your room temperature, right? While your room temperature is constant, right? You do that for your bag. So that means at room temperature in this case, or at a constant temperature, temperature, when there is increase in the pressure, volume will decreases, and this is Boyle's law. Okay, now we go to the second case. So this is now the first case. Okay, what is the second case now? The second case, as we said, in each case we need to make one of these three quantities, which is pressure, volume, temperature. We need to make one of them constant. Okay, in the second one, we're gonna make here pressure constant. So pressure here is constant. Pressure is constant. Now we are studying what? We are studying the relationship between temperature and what? And volume. What is the relationship between them here? So pressure here, we're gonna put it here constant. As you see, we're gonna make it constant here at this point, which is what? 9.2 atmospheric pressure. Now we are studying the relationship between temperature and volume. Okay, now if we increase the temperature now is 150 Kelvin. If we increase this temperature, what will happen for the volume? What do you think? If we increase the pressure, that means we increase the heat of this container. What will happen for, as you see, these gases are in continuous movement. Okay, now the temperature is 150. If we increase the temperature, look here now, if we increase the temperature here now, as you see, while the temperature increases, what will happen? What happens to what? To the volume? As the temperature increases, the volume what? Increases. So that means the relationship between volume and temperature is directly proportional. Okay, now same thing now, if we decrease the volume, what happens now? When you decrease the volume here, if it is related to the pressure, when it is constant, when we decrease the volume, that means the temperature is what? Is decreased, increasing, decreasing. So that means we put here now, when the temperature here increases, the volume increases. When the pressure is what? Constant. And this law, by the way, is called what? Keep it in mind. It is called what? Charles' law. So what is Charles' law? Charles' law states that at a constant pressure, the relationship between temperature and volume is directly proportional. Directly proportional, that means if we increase the temperature, the volume will increase. And how to link that in your life? How to link this idea in your life? Remember when you go to see, like if you remember the bridges of the cars, we have a bridge. Usually when we design a bridge, when there is a bridge, when you build a bridge for cars, we usually put a space. We usually put a space between its parts. And this space, by the way, we allow the expansion of these parts. So that means, when does the expansion happens? If you increase the temperature. So in general, if you increase the temperature of materials, in general, its volume increases. Its volume what? Increases. So that means for bridges now, when we put a space between the bridges of the cars, usually at summer or on summer, when there is increase in the temperature, these parts of the bridge will increase. So that means we put them space in order to give them allowance for this expansion. This is how to link it into your life, and this is a Charles' law. And to link it, as you see, Boyle's, we said to link it with boiling. That means constant temperature. Charles, from cha, there is pressure cha. So that means Charles pressure cha. So link it with it with is what is constant. So Charles pressure, Boyle's temperature, and we link it with what is constant. Then we study the other ones with the other two quantities. Okay, the third way here now, we are going to study now the relationship between, which is the third part. We are going to study what now? We are going to study the relationship between, here now temperature is constant, and here now pressure is constant, and here we're gonna make the volume constant. Okay, when we make the volume constant, that means we are studying what two quantities? We are studying temperature and also what? Pressure. Okay, we can think of it now logically. If the volume is constant here, if the volume is constant, as you see here, the volume now is constant. What would happen if we increase the temperature? Now the temperature is 180. If we increase it now, what would happen for the volume? I mean for the pressure here. What would happen for the pressure? Look here now, as you see, we want to increase as you see, when we increased the temperature to 207 Kelvin, what happens to the pressure, by the way? It increases. Why? Why does that happen? Why does that happen? What happens exactly on this part now is when we increase the heat here, that means we are giving these particles energy. So we increase the heat. Heat is type of energy, and it is transformed as a thermal energy from a hot body into what? Cold body. So this one now, there is heat transformed into this what? This container. This heat now as a thermal energy, and this energy, thermal energy now, when it goes to these particles, it increases. It is transformed. This energy, as we know, energy is neither destroyed nor what? Nor created, but it can be changed from one form to another. So this energy now, when it is transformed into these gases, it will be transformed into kinetic energy. So it will increase the movement, it will increase the speed of these particles. So these particles will move in higher speed. So that means the temperature is the average of the kinetic energy of these particles. So that means when the temperature of these ones, now these particles increases, that means its average of kinetic energy increases. So that means the kinetic energy in general of these particles increases. That means the speed of these particles increases. When this speed increases, as you see, the speed now, when they move with higher speed, that means when they collide to the wall of the container now, they collide now faster. When they collide faster, so that means they knock the wall of this container with higher force. So higher force means higher what? Pressure on these walls. So that means when you increase the temperature, as this increase, the movement or the kinetic energy of the particles will increase. So that means the collision now of these particles into the wall of the container will be greater. That means it will increase. So in this case, the pressure will what? Will increase. So when we study here now the temperature, when we increase the temperature, pressure will increase when the volume is constant, and this is called what? Gay. It is called what? Gay-Lussac law. Gay-Lussac what? Law. So that means now we studied 3 laws, as you see here now. Temperature is constant, this is Boyle, and the relationship between pressure and volume is inversely proportional. Second one, which is a Charles' law, when the pressure is constant, the relationship between the temperature and volume is also directly proportional, but here, directly what? Proportional. The third one was the volume is constant, the relationship between the temperature and pressure is directly proportional. So you have 2 directly, which is number 2 and number 3, and you have 1 inversely, that is only what? Which is the first one, which is what? Boyle's law. So we studied now the 3 cases, and you understand what each one is called and who said that one. So to link Gay-Lussac here, as you have 2 names here, that means it's related to volume. Volume of the name is greater, so that means the volume is constant. When the volume is constant, remember here the temperature and pressure. Increasing the temperature, that means increasing the kinetic energy of the gases, that means increasing the collisions or the force of collisions on the wall. In this case, the pressure will be increases. Okay. If we go now to these equations, which is Boyle's and Charles and also what? Gay-Lussac. Okay, the first one, which is what? Boyle's law. Okay, in Boyle's law, we said, in Boyle's law, the temperature is constant. When the temperature is constant, we said that pressure and volume are what? Are inversely proportional. So that means if you increase the pressure, the volume will decreases. Okay, how do we write this one now as a formula? We write it this way. P1, V1, look, when the relationship is inversely proportional, put that in your mind, and for all the time, when the relationship is inversely proportional, you can write it as a multiplication. So P1 times V1 equals what? P2 times what? Times V2. This is when it is, as you see, inversely proportional. When one increases, the other one decreases. Okay, what about the second one, which is what we said, Charles' law. Okay, Charles' law, what is constant? We said that that means pressure here is constant. When the pressure is constant, that means we are studying what? We are studying the volume and also what? The temperature. And we said directly proportional. When you increase the temperature, of course, the volume will increase. And we said you can memorize that like the summary and expansion of things. So here now, how can we write this formula now? V and T. If the relationship is directly proportional, you can write it as division, not multiplication. So that means you can write it like V1 over T1 equals V2 over T2. I hope that is clear now. Okay, if we go to the third one now, third one issues we said what? It is Gay-Lussac what? Gay-Lussac's law. Okay, in Gay-Lussac's law, what is constant? The volume is constant. We said if the volume now here is constant, that means we are studying what? We are studying the relationship between pressure and temperature. We said that the relationship is directly proportional. So that means if this one increases, the other one decreases. And how we write it if it is directly proportional? We said we write it as division. So that means it can be P1 over T1 equals P2 over what? Over V2. So this is now Gay-Lussac's law. So that means, as you see, have now three formulas. This is the first one, and this is the second one, and this is the third one. And we know in each law what is its formula and what's the relationship between each two quantities and what is the one that is what? That is constant. Okay, so you have here, as you see, 1, 2, 3 formulas. Okay, now what is the fourth one? If we combine all these ones, can we combine them in one formula? Can we combine these ones in one formula? Yes. If we want to combine these ones in one formula, we put here now, as you see, fraction on the left and fraction on the right. And as you see here now, only what is in the denominator. Here, there is no denominator. Here, the denominator is T1, T1. Here, the denominator is T1. And here, this is, by the way, this is T2. This is also what? T2. Get P1 over T1 equals P2 over T2. So this one here is T2. Okay, so the denominator now is T2. So we write it here, T1, and here we write what? T2. So the denominator is temperature. Okay, what is in the numerator here? As you see, if you go back, this is combined for all of them. The numerator here, pressure, pressure. And the numerator here is volume and volume. So that means you can put them together as this way. So that means P1, V1 equals what? P2, V2. And this is now called combined gas law. Combined gas law. What is combined gas law? As you see, if it is like a collection of the three formulas in one formula. And from the combined gas law here, look this one now. If you memorize this one, that means you are memorizing the previous three. How? If I memorize this one now, if I go to the first one, which is Boyle's law says the temperature is constant. When the temperature is constant, that means cancel it from here. What will be left? P1, V1 equals P2, V2. So that means what is left is exactly this one, you see? Okay, what about if the Charles law? Charles law, pressure is constant. So the pressure is constant now. Cancel the pressure from this one. What is left? V1 over T1 equals V2 over T2, which is this one, you see? Exactly this one here. Good. And if you are talking about Gay-Lussac here now, law, that means you are talking about the volume is constant, so cancel the volume from here. What you'll get is what? P1 over T1 equals P2 over T2, which is what? This formula. So this is combined gas law for the three formulas. So now we have, as you see, we understand now what is Boyle's law, Charles' law, Gay-Lussac's law, and we understand also what is combined gas law. Okay, we have also fifth formula here. I'm going to write it, which is called ideal gas formula. Ideal gas law. Ideal gas law, it is P1 or P times V equals N times R times T. Here, T is the temperature we know, and V is the volume, and P is the pressure. And R is a constant, and N is number of moles. N is number of what? Of moles. And we're going to use this one in formulas, by the way, in problems, in solving problems. So this is now what is called what? Ideal gas law. Okay, what are ideal gases? Ideal gases, they are theoretical gases. That means they are not in real there, but they are theoretical there. That means we suggests that there is something called ideal gas. Ideal gas, that means they are very small. That means they are like non-existing. That means in their volume, and they are like points. Their attraction is about 0. They have no attraction or repulsion between each other, and they move in a constant movement or in a straight lines. That is, this is what you think about ideal gas, but they are not there in real. So this is its law now. We deal with gases sometimes like ideal gases in order to make the study of gases easier. Good, so it equals now pressure times volume equals N times R times T. So we know what is the pressure and we know what is volume, and this one is number of moles and this one is the temperature. The temperature usually in Kelvin. The temperature usually in Kelvin. And number of moles, this is real number. It's gonna be like integers, which is what whole numbers 1, 2, 3, 4 number of moles. Good now, but here pressure and volume. Pressure, it can be in Pascal and it can be in atmospheric pressure units. That means it has 2 units. It can be in Pascal, it can be what? In atmospheric pressure. And volume, it can be in meter cubic, which is the SI unit, or it can be in liters. So that means you have 2. So that means this case now, the R will be different. The R will be different. If we are using the pressure in Pascal, and you are using this one in meter cube, in this case, the R will become around like 8.314. And its unit will be here, Pascal, meter cube over moles times Kelvin. This is its unit. But if we use the pressure and the volume, if we use the pressure here in this case, if we use the pressure in atmospheric pressure, and we use the volume in liters, in this case, the R value will be different. It's going to be like about 0.082, and its unit will be what? Atmospheric pressure, which is atom times liter over mole times Kelvin. I hope that is clear now about these 5 ideas. Good. If we go now to another idea here, and it is very important. First, we know what is STP. This STP, it means standard temperature and pressure. For gases, standard temperature and pressure. Standard temperature, it means 0 Celsius. 0 Celsius. Good. And pressure here, it means 1 atmospheric pressure. So this is for gases. Standard temperature and pressure, which is STP, it means 0. When does that happen? When does this case, when we call it a standard conditions for temperature and pressure for gases, when the temperature is 0 Celsius and the atmospheric is 1 atmospheric pressure. Good. Okay, what we use this one here? We use it just in ideas when they tell you at atmospheric pressure STP, so you know what does that mean. Instead of telling you what is the temperature, what is the pressure, just they tell you in the question STP, and you understand what does it mean. Okay, now just we have an idea. If I have here a container of gases and here a container, another container, and they have the same volume. This is V1 and this is V2. And they are equal. They have the same volume. Good. And both of them, they have the same what? Pressure and the same temperature. Both of them, they have the same pressure and the same what? Temperature. So that means here, this one are equal, the pressure and also the temperature is equal. Okay. Here now, I have now number of gases inside. For example, like hydrogen gases, and here I have another gas like oxygen gases. Okay, I have particles now. The question now, if I have the same volume containers, and these containers, they are in the same conditions of pressure and temperature, and they are different gases like hydrogen and oxygen, or hydrogen or another gas like water gases or whatever. So in this case, which of these containers will have higher number of molecules? higher number of molecules. We know now that if we count these number of molecules of gases inside the left container and we count these number of molecules inside the right container, we'll see that they'll have the same number of molecules, the same number of particles, regardless what is the type of gas, regardless what is the type of what of gas. And this is what is called Avogadro's law. So what is Avogadro's law? It says that at same conditions of pressure and temperature, same volume will have same number of particles, same number of particles of gases. So you need to memorize that. We need to memorize what? That. And also, if we have STP, that means you have a container now, and this container now, it has STP, and we said it is standard temperature and pressure. Standard, that means temperature is 0 Celsius, and here the pressure is what? 1 atmospheric pressure. Good. 1 atmospheric pressure, and we know that 1 atmospheric pressure, it is around 103 kilopascal. Okay, this one now 1 atmospheric pressure, and this one here 0 Celsius. Good. If we have 1 mole of gas here, 1 mole of gases, 1 mole, and we know what does it mean 1 mole? 1 mole, it means Avogadro's number, which is 6.02 times 10 to the power of 23 of particles of gas. Okay, if I have this number now, this huge number of particles inside this container now, what will be the volume that these molecules will take? Again, what is the volume of 1 mole of gases at STP? And this one you need to memorize it. Again, what is the number of, what is the volume of 1 mole of gases that are under STP? In this case, it can be constant, which is 22.4 liters. So that means if I have 1 mole of gases and they are at STP, in this case, they'll take a volume which is 22.4. Okay, what about if they are 2 moles? What will be their volume? Will be twice this volume. It will be 44.8 liters. Okay, I hope that is clear till now and you understand gases and the combined 6 ideas related, which is 5 laws and also Avogadro's law, which is combined with STP. Okay, just we add last idea is how to convert between the degrees of Celsius. We have this formula, as we know. If we have Kelvin, how to change Celsius into Kelvin? Just we add what? 273. If you want to memorize this number, you can write it, you can memorize it like 27 is a cubic number. 27 is a cubic number. It's cubic like 3. So 27 is a cubic number. This one is the number that you added to the Celsius in order to be changed into Kelvin. So if you have 1 Celsius, just add to it 273 in order to be changed into what? Kelvin. And the number of Kelvin usually higher than the number of Celsius. Good. This is how to convert from Celsius to Kelvin and Kelvin to Celsius. Okay, what about Fahrenheit? If you want to change Celsius into Fahrenheit, just multiply the Celsius by a ratio. What is this ratio? It is 9/5. Then you add plus 32 as what? As constant. This is now how to change from Celsius into what? Into Fahrenheit. Good. And remember that if we heat water, by the way, it gets evaporated or starts evaporating at 100 what? Celsius. And if we freeze that water, it starts, or the point of freezing, it is what? 0 Celsius. And this is the measure of what? Of Celsius. So that means the Celsius measure, it was about water when it is freezing, and it is what? Evaporating. So that means evaporation and freezing, the distance or the change between the range between them is 100 Celsius. 100 means that time of evaporation, and Celsius, 0 Celsius is the time of freezing. So you understand these ideas now, and we are ready to solve any question related. Thank you so much. See you in other videos.